Pharmaceutical research plays an important role in the drug discovery process. Companies invest billions of dollars on research and analysis. However, to find key information, researchers need to comb through data from various internal and external data sources. They need to separate quality data from noise, and they need to summarize and analyze this data quickly, while protecting the data and adhering to regulatory requirements. AWS's AI-powered multi-agent solution addresses these problems. It helps researchers fast-track their research by autonomously combing through millions of articles on PubMed, analyzing clinical trials, searching through molecular databases, and reasoning with the collected information to understand the clinical and scientific relevance of the problem. Using generative AI services from AWS like Amazon Bedrock and capabilities like agents for Bedrock, life science researchers can build an agents framework that allows them to perform research and take action across multimodal healthcare and life science data sources or action groups. Let's walk through a practical example of this. Imagine a researcher who wants to create a comprehensive scientific article about biomarker-guided breast cancer. As you can see in the query, the researcher is specifically interested in biomarker information, genetic, demographic, and epidemiological information, and breakthroughs that are currently in trials. Let's look at how our multi-agent framework approaches this problem. The planner agent comes up with a plan. Because the planner agent is aware of what action groups are available, it can start mapping the steps to specific action groups. For example, it uses the PubMed action group to fetch information from the literature about biomarkers, genetic subtypes, and diagnosis. It also uses the clinical trials action group to fetch information on relevant trials. Next, let's look at how the executor agent executes the plan. For every step in the plan, the executor agent executes an API call with appropriate API signatures and inputs. The planner agent then reviews the output. If the output meets the objective of that step, it moves on to the next step. If not, the planner agent modifies the plan by adding a new step to modify the input, or going to a different action group with a different API signature and input. During this execution, the executor agent provides the raw output from the action groups, and the planner agent interprets and suggests next steps that the executor agent should take. This process repeats for each step until the executor agent has all the information needed to generate the final report. Now, it's time for the agent to construct the final report. To do this, the agent reviews all information gathered in each of the previous steps and puts that information into different sections of the report. For example, it creates sections for introduction, population characteristics, breast cancer subtypes, and recommendations for future trials. It also puts summary information in tables when necessary to represent the data better. The final report is reviewed and presented to the researcher in a markdown format by the agent. As you can see, the multi-agent solution looks at a variety of datasets to generate this report. The modular nature of the agent's platform allows you to extend it to multiple other action groups to reference both internal and external datasets. Typically, the creation of a report like this would take a researcher multiple days of searching through information and curating it in a meaningful way. However, by using the agent's framework, they can save valuable time that can be spent doing more meaningful research. Leveraging AI-powered solutions such as generative AI agents reduces the time it takes for researchers to get qualitative and quantitative data, and therefore reduces data fatigue and decision paralysis. This gives researchers more time to deeply analyze the observations in the report, add new data points, and improve the quality of their research.